Municipalities and chemistry, do they go hand in hand? Well, actually they do. In fact, we're going to be looking at, in this second keynote session of Stormwater Awareness Week, at the chemistry of stormwater for municipalities. So why don't you join us? Okay, what does chemistry have to do with municipalities and municipalities with chemistry? Actually, you'll be surprised to see quite a bit, especially when it comes to the Phase 2 MS4 permit. In today's keynote session, we're going to take a look at two specific areas. The first one, Section E9, which deals with illicit discharge detection, and then the second one is going to be sections E13, E15, talking about TMDLs. And to do that, I've invited a couple of guests. So our first guest I want to invite up is Steve Taraska. So Steve, would you please join me? All right, Steve. Well, thank you for joining us, and welcome to the show.
Thank you.
All right. Well, how long have you been with WGR?
I've been with WGR a little over 15 years.
Okay, and you're a senior compliance specialist, and
Yes.
and you head up our municipal permitting program.
Yes.
And it's no coincidence we have the same last name, right?
No, I think we're related somehow.
Yeah, somehow. I think he's my little taller brother, bigger brother, taller. But anyways, I am the older brother. But welcome to our program, and thank you for helping us understand this permit. Now, when it comes to the Phase 2 MS4 permit, what types of activities are you involved in?
We work with municipalities pretty much up and down the state. Like you said, Phase 2s, we have a couple Phase 1s, but pretty much anywhere from Reading down to Merced, we're working with municipalities implementing this Phase 2 permit and all of its requirements, including this E9 section.
Yeah, in fact, this E9 section deals with illicit discharge detection. And what types of tasks or activities are required of municipalities under E9?
Really, it started off in the beginning of this permit term with just getting your hands around your stormwater system, so you understood where water flowed to. When it goes into a drain, where is it going to come out? The next part of it was really understanding who are the players in your city. So you're looking at the industrial facilities and your commercial facilities, and get them all on an inventory.
Okay.
and understanding where they are and what they do. And then finally, it's kind of looking into what's going into our system and how we're going to react to things that are non-stormwater going into our system, which is this whole illicit discharge detection, elimination portion of it. And so, and it includes doing some inspections, going out, and if we find something, what are we going to do? We need to sample it, and then what do those samples tell us?
Yeah, I guess we should say that, this being Stormwater Awareness Week, when it comes to municipalities and their drainage systems, it's really back to the old adage, only rain down the drain. That's what our goal is, right?
I like to say that with a little asterisk, because there's a few other things that can go down the drain, but that's the mentality we want to keep, is primarily only rain down the drain.
Okay, and so there are some things that are allowable, and what would be those types of things?
Things like uncontaminated groundwater, air conditioning, condensation, non-potable water sources, and the little asterisk to that is as long as they're not conveying a pollutant. If you have air conditioning condensation coming off this roof and washing across a dirt lot and picking up dirt on the way to the storm drain, that is now a illicit discharge, because you are discharging pollutant. If it was just straight air conditioning condensation, then that, according to our allowable list, would be allowable.
So those are some allowable, but illicit, I mean, that's a pretty strong word, illicit. What would be illicit?
If it's not stormwater and it's not on that allowable list, it is illicit.
Well, that covers a wide range. And,
Sure.
And I guess that's part of the problem, right? Is, okay, you see a flow going down the curb and gutter. How do you know what it is?
Exactly, and you don't unless you know the source, or you need to start looking into through analytical methods where that source is
Is
coming
that
from.
where chemistry gets involved in this?
Yes, absolutely. And if you look at the E9 section, there's the Table 1 indicator parameters, and this is a list of parameters that the Water Board has given us to kind of look at our discharges and identify by doing some simple chemistry test, or we'll see how simple they are, but what we're potentially dealing with and what is the smoking gun that we're going to go chase.
Okay, and I should tell some of our viewers that we've provided this as a resource. They can go to the stormwaterawareness.org website, and under the tab that says resources, we actually gave them an excerpt of the things we're talking about today. We didn't give them the whole permit. They can go to State Water Board website for that. But there's an excerpt, including this Table 1, which we'll be showing throughout the broadcast too on the screen.
Yes.
So, all right. Well, Table 1, all right. How is this used then for us to do some, I guess, detective work is what we're doing, right?
If you look at the Table 1, the first column is going to be parameters, and these are really the clues to what we're potentially dealing with. And so we're going to sample our unknown discharge sources for these parameters, and they include ammonia, color, connectivity, detergents, surfactants, fluoride. A lot of municipalities have swapped out fluoride because they do not fluorinate their municipal supplies anymore, and they have substituted chlorine or residual chlorine in its place. Hardness, potassium, and turbidity. And then the next couple columns you have there is potential sources that when you start sampling your discharges for these analytes, when you start getting different hits, it's going to show up in one of these columns. And these columns, typical columns you would be dealing with would be sewage, wash water, tap water, industrial or commercial liquid waste. And that's just kind of a snapshot. This is where you should start looking.
Okay, I see. This is a little different than your typical permitting requirement to do analysis, because lots of times we do analysis to compare to like a permit limit. But we're doing analysis here for a different purpose. It's really to do some detective work and figure out whether it's sewage, wash water, or what is it. And so it's not so much that we're comparing it to a permit limit.
No, and there are some additional limits, and we'll talk about that as we go down the line, but that's more of, okay, how big of an issue is this discharge going to be, and how much more follow-up do we need to do, and the Phase 2 permit kind of talks about, if you start hitting these action level concentrations, then you'll need to go do more of an intensive investigation to find a source.
Sure.
But this is not your typical stormwater sampling. If you're a construction permitting, you're sampling for turbidity and pH, or you're an industrial facility and you're sampling for metals and pH and some of those type of samples, and you're collecting your overall to meet limits.
Right. And speaking of which, going down this list, there's quite a few things that are kind of unique. We see pH and turbidity, and we're familiar with that. But detergents, surfactants, is this something that we're sending to a laboratory? How are we approaching this?
A lot of municipalities will simply, just for the ease of handling it, collect their analytical samples in the lab-provided sample bottles and send their samples to the lab. There's some advantages and disadvantages of that. The advantage being you don't have to purchase all of this equipment. You don't have to maintain all of this equipment. This equipment is pretty expensive. That turbidity meter right there typically runs around $800 to $1,000, depending on what model you're purchasing and everything.
Yeah.
And then there's ongoing cost of calibration solutions that are going to run you another $300 to $400 a year to maintain. Even as simple as these ammonia strips, these are consumable materials that you'll have to continually maintain. And then there's the education factor of educating your staff to know how to operate this equipment.
Sure.
So it's a little daunting. A lot of municipalities have chosen just to simply go to a laboratory.
Right.
The advantage of going to the laboratory is, they have somebody else handle it
You
for
just
you.
fill up a bottle.
But the disadvantage is you're going to wait 5 to 10 days to get your analytical data back.
And is it important to have a timely response or results?
If you're going to chase an illicit discharge isn't necessarily always ongoing. It could be one day and gone the next, or 1 hour, and by the time you're ready to respond, it's gone.
Yeah.
So it's useful to kind of have your results more immediate. However, this isn't always practical, and the permit has given us kind of a either or approach, or you can go either to the laboratory or you could self-monitor. We, with the municipalities we work with, we like to take a hybrid approach because a lot of municipalities have some of this equipment at their disposal, or some of it is not that expensive. So things like the turbidity meter, if you're a construction, or if you have construction activities, or you're a construction inspector, you may not have that piece of equipment already in your arsenal. Same thing with a pH pen.
Well, can you go through some of these? What is this?
Okay, this is a potassium analyzer, and so this is very much like the turbidity meter. It has a vial that you fill up, and there's some activator reagents, and then you go through a process of zeroing out the machine, and then putting your sample in there, and then analyzing your sample, and it'll give you your
So
potassium
I noticed
results.
that a high potassium would mean industrial commercial, possibly.
Yes, and possibly a indicator of a potential sewage.
Now pH, I believe it's this one right here. We've seen this. We saw this on Monday, and I think we're going to revisit pH for construction. So pretty common test. pH can help us give other clues. What about what's this blue tube here?
So this is detergents, or the MBAS test, and this one is pretty simple because it's a couple of snap-off vacuum seal vials that once you run this test, you'll compare your analysis, and you can kind of know where you are pretty quickly. So this is another example of instantaneous results versus a 5-10 day turnaround from a laboratory.
Okay. Now, color. That's something that we don't see a lot in NPDES permits, at least that I'm familiar with. What are we checking for color?
We are looking at the tint of the water.
Okay.
So is there a noticeable color difference? And going back to that action level concentration, sorry, wrong permit. The action level.
You're referring to Table 2.
Table 2. The action level for color units is 500 units, which is way out there. You have colored water at 500 units. This particular unit, it had the color wheel it came with. In fact, we can pop it open and look at it for demonstration. Inside here there's a color wheel, and you'll turn the color wheel. This color wheel maxes out at 100 units.
Okay.
I've done quite a bit of illicit discharge monitoring for municipalities. Rarely do we get over 20 units. I mean, the water is just not typically that much.
And I think I've heard you say that you've selected a hybrid approach. Not only do we, maybe take some samples to the lab, but some you'll pre-screen. I believe, if I remember right, it was ammonia.
Yes.
These test strips go up to 6.0 parts per million, right?
Right. We, when we first started acquiring a lot of this analytical data, or analytical instruments, that is falling apart.
It's live television.
Yeah, we purchased a lot of expensive equipment, and like I said, a lot of it had expiration dates for calibration equipment. And one of the pieces of analytical equipment that we couldn't get our hands on and maintain for a reasonable price was ammonia, and it just didn't make sense. So we kind of had the idea of, hey, I think if we go to the aquarium store, we can get some ammonia strips that'll kind of give us a snapshot of if ammonia is an issue. And so these strips will read up to 6 ppm or milligrams per liter of ammonia. And so this is your first indication, do I have ammonia in my sample? If you start maxing out this strip, then that's probably a good indicator that you probably want to send it to the lab to check if you're going to.
But if you're under, then you know you're golden.
You've eliminated that.
Okay, okay. Same with the chlorine. It has a limited range.
Limited range, and actually, if you look at the allowable discharges, there shouldn't be chlorine in our water. Most of the discharge prohibitions say if you're going to discharge pool water, it needs to be dechlorinated pool water. So you really shouldn't have chlorine in your water. Municipalities put a little bit of chlorine in their water, but really it shouldn't show up on that test too much.
And if it does, maybe it's indicating something else.
Something we probably should be looking into.
Maybe pool water. Maybe somebody's discharging some pool water or something else. All right. Well, good. And I think we've pretty much gone through things now.
So, we kind of gave an overview of these sample kits here, but I like to take more a hands-on approach. And before I came here this morning, I actually collected some water that maybe we can put these to work.
You going to tell us what city you collected it in?
Anytown, USA, I believe is the name of it. It's on Main Street.
That's a wise move. I think we got Bill Harris here with the State Water Board. So,
and a few
but you were busy this morning. You got 4 illicit discharges.
Yeah. So,
all right.
Why don't we step over and check it out?
Yeah.
All right, so as you can tell, we have 4 different samples here, and each of them have a little bit different look to them. So obviously, we're talking about color, and we can look at each of these, and we can tell that we probably have a color issue with maybe a couple of them.
Yeah.
But
I mean, some of these look kind of gross, like this one. Look at this.
And actually,
where did you get this? That's pretty disgusting.
Yeah, we don't want to talk about that. Which reminds me, before we start handling samples, we want to make sure that we wear proper PPE.
Especially looking at number 2, I think that's probably wise.
Yes. So let's put on some nitrile gloves to just kind of protect your skin.
All right.
Early on in my career, I worked with I responded to a illicit discharge at a refinery. And when I was walking down to collect samples down in the channel that was at the refinery, they told me it was an acid spill, but I wore my gloves and everything, but by the time I got down to collect the samples, my boots had melted.
Oh, wow.
So that's just another reminder that you want to remember that you always want to wear proper PPE.
That's true. That's a good reminder because, when we see water going down the curb, I think most of us think it's sprinkler water. It's somebody washing their car, but it could be something pretty bad.
And a lot of the municipalities that we're working with were going down to the waterways where, unfortunately these days, just because of situations, that there's a lot of homeless encampments going on there. And a colleague of mine were out at a site yesterday, and we were going through a lot of homeless encampments, and when we're on our way to look at the outfalls, and there's some dangers there. There's biological dangers. There's there could be some things that we really want to protect our feet. We want to protect our, don't want to go out sampling in shorts. It was 90 degrees yesterday. That would have been really fun, but you just want to really take protection. Plus, the water. Let's talk about this water that's coming out.
Okay.
We don't know where it came from. That's why we're doing this. And so, just more reason to...
Can we do some detective work then?
Yeah, absolutely.
All right, we got number 1 here. You've labeled them 1, 2, 3, 4. 1, I'm afraid to say what that looks like.
Yeah.
But
so let's put a couple of these tests to work. The potassium meter is right there on the end.
Okay.
Why don't we try that one?
Do you need a reagent?
Yeah, I do. There's a little drip bottle that probably didn't make it out here. Live TV. So while John's looking at that, what we're going to do here is we're going to turn this on. And there's a couple different settings. There's the low setting, so if we know that potentially we're going to have low potassium hits on here, we would be at the P1. There's a higher reading. There's a P2. But again, there's a vial right here.
This one?
No, it's a little drip bottle. Why don't we get a little audience participation? Brandon, would you mind coming up and finding that drip bottle? So in this vial here, we will fill this up with our sample. And so when we're taking samples, it's a good idea to not only we're going to run analytical samples, but we use our senses too. Thank you. And then there's actually also, Brandon, there's some packets in there, the activator packets. Thank you. You want to use your physical senses. So the sight, obviously we're looking at this, and this is not a typical color that we see in nice clean water. So that's an observation right there. The next is smell. So is there a smell? I don't really pick up an odor.
No, just your clone.
Okay, how's it taste? No, don't use that. Don't use that. So, okay, what we're going to do is we're going to transfer, and I'm going to do this over the sink here because my hands are not steady. Is it transfer? Oh, goodness.
I hope it isn't what it looks like.
Hopefully it's not caustic and going to burn through the desk. Good thing my nitrile gloves are on. Okay, so there we go. So we filled our sample vial. There are fill lines right there. And let me get to the fill line. There we go. And we are going to do 6 drops of the activator. So count with me. 1, 2, 3, 4, 5, 6. And then we are going to mix our sample together. Do a little dance.
Thank you, Brandon. You're welcome.
How about a hand for Brandon?
You saved our lives.
Thank you, thank you. All right.
It's a good thing you were out with Steve at Stanislaus yesterday.
Good thing.
Oh, don't give away.
No, we didn't get these at Stanislaus.
Okay, so just for reference, we are going to zero this out. So we run our sample with those 6 drops, and we hit 0, and the meter is just going to read that sample and basically zero it out.
So this is a test for nitrates. We're looking at
nitrates.
nitrates. And nitrates, according to table 1.
I'm sorry, potassium.
Or potassium. Thank you for correcting me. So table 1, potassium, it has that dark dot. If you notice, if you're looking at the table 1, it's got 3 different types of dots. One is completely filled in, and that means that it's almost always an indicator that it could be from that source. So in this case, that would be industrial commercial. Then you see another dot that has a circle with a dot inside of it that says it sometimes could be an indicator, and then a clear circle, nothing inside it, a white interior, means it's probably not a good reliable indicator.
Yes, and
So for industrial commercial, potassium is actually the only one that has the dark dots. So if you get a strong hit on potassium, then that's
we
a
probably have a good smoking gun to start
pretty good
looking
indicator.
at, start our investigation. So what I did is I added the potassium reagent B. So this is the second part of this process. And then I'm going to put this in here, and I'm going to start a timer, and it's going to do a 2-minute timer. Instead of us just all staring at this for the next 2 minutes, why don't we run another test? Why don't we run connectivity for this sample? And so I'm going to hit the read timer, and countdown begins. 2 minutes.
All right.
Okay, so this is connectivity. So this is the measurement of, this is a good indicator that maybe that we have some salt sources. Connectivity is also high typically in groundwater. There's the action 2 level concentrations on table 2. And if you look at these action level concentrations, you'll pretty much look at each of these and you'll see that they're really high. Ammonia, if you have 50 milligrams per liter of ammonia, you're probably going to know it. You probably know you have an issue.
It's going to knock you over.
Yeah. Color 500 units, and we'll test that one. Connectivity, it's 2,000. This is one that I've actually seen be exceeded before, or be at that level before because of groundwater. And if you look at that allowable list that we were talking earlier, what is groundwater? It's allowable. So as long as it's not picking up a pollutant, uncontaminated groundwater. So our investigation, if we truly found that that source is groundwater, would start and end with that, that result. So we're going to go ahead and sample for connectivity, and we are dipping this in here, and immediately it jumps up to pretty high connectivity. We are
1540?
1540.
Wow.
So that is really elevated. We didn't go over our action level concentration, but we are close.
Wow.
And so there's a good indication.
So conductivity actually is the only one that would exclude most likely would be tap water. So we know it's something other than clean tap water.
Yes.
Then, so it looks like we got 12 seconds, 11 seconds left on our potassium.
Okay.
And we can see color. You know, we're obviously these tests take some time to do. So we don't have a lot of time in this 1 hour program, but we can see there's color there. It's obviously different than this one here.
Yes, and so read timer. We hit the read button, and we had a potassium reading of 10. So again, that's pretty elevated for potassium, but we didn't exceed our action level concentration at 20 milligrams per liter.
So we have some time to just look at the others briefly. Let's just summarize what we know. We got high potassium, we got a pretty good color. I mean, we can see the color, and we got pretty good conductivity. So that's kind of leaning us towards, it looks like maybe the industrial commercial.
And so with those results, it probably should start to prompt an investigation. Okay, we know that this is not typical water coming out of our drainage system. You know, this is probably not meeting that potable water source. It's definitely not stormwater because we have dry weather. So this should start an investigation, and you would need to start going upstream. So you use some of those tools that you developed early on.
Right.
You use your drain map, to look at what are the upstream sources, and you start doing a trunk investigation. And you know, as you can chase the flow upstream, you start eliminating lines.
Sometimes it's obvious, sometimes it's not.
Sure.
Now, what if it's obvious? I see water coming from somebody washing their car and going into a drain inlet. Then do I need to test?
No. If you know that source, and in fact we had that yesterday at one of the sites. We went to an outfall that is typically dry this time of year, and on the way into the outfall, we saw a broken water main with water flowing out of the surface and going right into the storm drain. Now, when we went down there, we know we typically, from doing this each year, we know we typically don't have a discharge here, so something was going on. That's a clue that potentially we have an illicit discharge.
A lot of things go into detective work.
But since we saw where the source of that was, we were able to come to the conclusion.
Mike, you still need to do some of these chemical tests just to test if you've exceeded action level?
Yes. Well, if you know where the source is, then you can stop the source, and then depending on what we're dealing with, then potentially you need to take some action against the discharger and some for some cleanup mitigation measures.
Well, this looks pretty nasty.
Yeah. So again, let's take our visual assessment of this.
I see solids.
We see solids.
I see little floatables.
Floatables.
Looks like paper to me.
You know, it has suds on the top. You know, unless and the fact that this isn't moving water. How does that smell?
Where'd you get this?
Oh, it's gotten better over time. So
I wish you could smell this on television. This is
smell-o-vision.
You know what? I don't need an ammonia test kit to know there's ammonia in here.
Let's try it though. Let's see what happens.
All right.
Maybe we're making an assumption there that it's ammonia.
Ammonia strips.
There's no doubt if you're sitting in this room that it's ammonia. But
you found this on your way to work this morning.
Yeah, all sorts of things. Okay, so give it a little stir. Oh, wow. This was yellow to start. I should have showed you guys that. In fact, I'll show you. If you look at my my color chart here, they go from yellow to green. This one went deep purple, and I'm not talking about the band. There's no smoke on the water. So, so right here, you know, that's where it started. That's where we wound up, and that was instantaneous. So we know
this is not good.
Again, this would be a good candidate that we're going to go ahead and send this to the lab.
Let's close that up.
To see if we're going to hit the 50. And if I was a betting man, I would say that we are going to hit the 50.
Just looking on our visuals right here, I mean, we don't even have to go a whole lot further. Ammonia's smoking high. In fact, ammonia on the list, the only one that is dark is sewage.
Yeah.
I mean, we see something. I mean, I don't have to be a rocket scientist to know.
Suspended floating materials, paper.
Maybe I need to be thinking SSO.
I would think SSO and
sanitary sewer overflow. So I got some reporting maybe to do besides following up on illicit discharge.
And that starts a quicker timeline than in the permit. Our actually phase 2 permit says if it's a suspected sanitary sewer overflow, as soon as you become aware of it, it's a 24-hour response.
Wow.
So you really need to be on top of that one.
This one's a lot different.
Number 2.
Yeah. Oh. This one is a lot different. Pretty clear.
Pretty clear.
Pretty clean.
So let's pop that one open and see what we're dealing with.
What would be your first go-to test into something like this? It's looking pretty clean.
Well, we're looking at it. Why don't we give it the smell test? And I'm picking up on a chlorine type smell, so good candidate, good call. Why don't we test the chlorine strips? And again, just like those ammonia strips, on the back of the chlorine, you know, we have a color chart. So we will go ahead and dip the correct end of this in. And look at that, instantaneous. You know, sometimes you have to wait for these to turn colors. If it jumps instantaneous to a dark blue color like that, you know you're dealing with a good amount of chlorine. Your nose would tell you you're dealing with this level of chlorine, and it was obvious.
Yeah, it smells like pool water.
By opening that up.
Did you get this out of your swimming pool this morning?
Possibly. Hot tub. But another thing.
Well, at least he chlorinates it.
Another thing to think of while we do a hybrid approach is if we don't have a smoking hot chlorine hit like that, more than likely by the time we get a sample to the lab, chlorine off gases really quick over time.
Yeah.
So this is a really cheap test. This is probably a good hybrid approach to start at this to tell.
Like you said, get you in the ballpark.
Right.
All right, well, we're running out of time. But this fourth one, if we shake it up, I mean, right there we can see suds, right?
Right. So,
and it's pretty clear. I mean, obviously, we're going to want to run all these tests. We just don't have time to do all the tests. But we're using visuals, too.
So I would say that's a good candidate for potentially detergents. You want to run that test? We got time for that, or?
I think we're running short on time because that does take a little bit of time.
So yeah, if we ran a detergent test, more than likely just seeing the suds, looking at the color of the water, you know, and knowing where I got that water, it was probably detergent. But that's basically an overview of these samples and really looking at. You know, it's an investigation looking for smoking guns because, you know, the first table 1 doesn't necessarily mean that we have an issue, but that's really a tool to kind of point us in the right direction and use some of the other tools that we've been given. So, you know, let's say we had the this first one that's highly likely coming from a commercial industrial source. We look at that inventory and see who could be kind of in that neck of the woods that would fit this bill, and then we can go kind of narrow it down maybe 3 or 4 facilities rather than, okay, where do I even begin?
All right. Well, now that you're taking your gloves off, I want to shake your hand. Thank you for coming up and helping us through this. In fact, what we're going to see next is a video that actually documents an actual illicit discharge detection process in the field. So we're going to watch this 11-minute video, and then we'll be back with Bill Harris with the State Water Board.
Have you ever heard of illicit discharge? Just warning you, it's kinda gross. Today I'll be learning about a non-stormwater illicit discharge. Do you know what those are? Well, in a minute you're gonna find out, unfortunately. In this video, you're going to learn how to detect where an illicit discharge is coming from and how to stop it at the source. I have to be honest, I didn't even know what to expect.
Rule that out, but I'm also looking to see if there are any floatables, and I don't.
Wait, floatables? The best way to prepare for something unexpected is to get another cup of coffee. So that's what I did. I got in the truck and I headed out to Stanislaus County to meet Les. He's going to walk me through all the steps that are involved in illicit discharge detection and elimination.
So you must be Les?
Yes, I'm Les. How are you doing?
I'm Brian. Nice to meet you.
Nice to meet you, Brian.
All right, so Les, tell me, why are we out here today?
Well, we're here to investigate what's called an illicit discharge.
Now, what is an illicit discharge?
Well, if you give me a couple minutes, let's go down and I'll show you.
All right, let's check it out.
Okay, follow me.
Okay, Les, so we're looking for an illicit discharge. Now, why are we looking for that right here?
Well, we start here because this is an outfall for our municipality, which is upstream from here. Anything that conveys from that municipality that is stormwater will eventually make it out to this outfall and enter our river down below us. But what we have today is a possible potential illicit discharge because we've had some really great weather without any rainfall for quite a while now. And I received a phone call about a potential illicit discharge coming out of our outfall. So that's why we're here, to see what it may or may not be and then investigate it from there.
So, what exactly is an illicit discharge? Well, have you ever heard the saying, only rain down the storm drain?
An illicit discharge is really a fancy way of saying something other than rain went in the drain.
Sometimes it can get a little bit more tricky than this because there are some non-stormwater discharges that are actually allowed to go into the drain.
Les told me I can find a list of allowable non-stormwater discharges inside the local municipalities' ordinances. However, even if something's on that list and it picks up pollutants on the way to the storm drain, that won't be allowed.
But an illicit discharge is anything that could be a sanitary sewer overflow that may enter our stormwater. It could be some kind of hazardous material that could be coming from a business. There are many things that are considered illicit discharges, but one thing to keep in mind is anything that is non-stormwater is a potential illicit discharge.
So how do you find out about an illicit discharge? Les mentioned that he received a phone call from someone telling him that there was a potential illicit discharge. Most of the time, it's your city or your county staff who are going to be the ones letting you know that there's an illicit discharge happening. However, sometimes other agencies and even the general public can get involved.
All right, Les, talk to me. What do we got going on here?
All right, what we have here, I do see some type of discharge coming out of our outfall here. And there are three things that, well, there's more than three things that I look for. But one thing I'm going to look for is to see the color of the material coming out. And from what I see right now, it is a fairly clear liquid, so I can rule out a couple of things. The first one is sanitary sewer. I'm going to rule that out, but I'm also looking to see if there are any floatables, and I don't see any floatables coming out of it. So sanitary sewer discharge is probably not the case here, but I'm going to rule that out visually.
Like Les was saying, visual observation is an important part of the illicit discharge detection process. Some of the indicators you should be looking out for are colors, odors, turbid water, sheens, floatables, algae growth, and damage to the surrounding area, which can come from caustic or hazardous materials.
So I'm leaning towards a non-stormwater illicit discharge that we have here, but we really won't know that unless we go upstream from this point and pop a couple of drain inlets and actually look and try to find the source of this material. Without finding that source, we may not know what it is, but if we do find the source, then we can at least know if it's a non-stormwater discharge or a hazard discharge of some sort.
Yeah.
But if we can't do that and we can't find the source of it, then we're going to have to actually take samples for an analytical laboratory assessment.
Okay.
If we find out that this is a hazardous discharge, then I have to respond immediately. And what I'm going to do is I'm going to contact and call my hazardous materials team and get them out here as soon as I can to assess the situation and clean this up. I may even have to call 911 depending on what we find out.
So the Phase 2 MS4 permit says in Section E7B1, subsection 2F, that illicit discharge procedures and contact information must be included in the municipality's fleet vehicles.
And no, I didn't make that up.
If this is a sanitary sewer discharge, then what I would do is I have 24 hours to get in touch with my appropriate response team to come out here and take care of and clean up the sanitary sewer discharge. Anything else, a non-stormwater illicit discharge, I have 72 hours to take care of this and respond to it. And what I would do is I would start my initial process of response through my municipality.
Got it. So why don't you run me through how we're going to go about tracking down the source now?
Well, what we'll do is from here, we'll look at a map that our Public Works Department has, and we know where all these systems are. So what we'll do is we'll go upstream to our a point where we can pull a drain inlet and look down into it and visually see if there's any material running. But if we don't see it running or any kind of material from there, then we're going to have to actually get a sample from here and determine what kind of material it is. But hopefully doing that, we can at least find out where this source is coming from. So let's go back up there and do a little bit of work.
All right, let's get to it.
Right, now that we're done with our initial investigation at the outfall, we're going to do what's called a trunk investigation.
A trunk investigation, man. We're driving trucks.
Not that kind of trunk. Hey, what a trunk investigation entails is we're going to go upstream and try to pop a couple of manholes to try to locate which direction our illicit discharge is coming from. And what I have here, I have a set of plans that shows us exactly where my municipality has these storm lines going. So first we're going to go up to the manhole that's just in front of us, and we're going to pop it, see if there's any discharge coming and from which direction. Hopefully that's going to show us which direction it's coming from, and if we go upstream a little bit more, pop a few manholes, and maybe locate our illegal discharger.
All right, let's get these manholes popping.
A storm drain network investigation is the most common and usually the most effective illicit discharge detection method.
So they call it a trunk investigation because the stormwater system map kind of looks like a tree. Now what we do is we try and trace the discharge up the trunk and through the branches to locate where this discharge is coming from.
Other possible methods for illicit discharge detection could include dye testing, sending a camera down the line, or making a list of facilities in that area that could potentially generate that kind of discharge.
That way.
Okay.
So we're going to follow it. So we're here. You see this manhole right there? Yeah. Put this back on and we're going to leapfrog and try to locate the source of this thing.
Les and I were popping open manholes left and right, and we figured out that the discharge was coming from industrial area on the backside of the town.
Someplace in between here and there, we lost it. So I've got some real bad news for you, Brian. And that is we have to go back to the outfall and we have to do some sampling of the discharge coming out of the outfall.
Okay, since we couldn't find the source of the discharge, what happens now?
Well, since we couldn't find the source of our illicit discharge, we do have to do some analytical testing. And first things first, we're going to grab some samples, but we're also going to have to put our gloves on because we do not know what kind of material we're dealing with. We don't know if it's hazardous, we don't know if it's sanitary sewer, so go ahead and put some of these gloves on. Right.
If you don't know the source of the illicit discharge, you'll need to collect some samples. These samples will give you some clues as to where your illicit discharge is coming from. Table 1 in Section E9C of the permit can really help you out with this part. By comparing your sample results with the indicator parameters in Table 1, you should be able to tell if the illicit discharge is sewage, wash water, tap water, or industrial or commercial liquid waste. For instance, if your sample results show high concentrations of ammonia, it's likely you could have some sewage on your hands. When it comes to sampling, you have two options. You can either test right out there in the field, or fill up some sample bottles and send them off to a lab. Les said that his municipality preferred a hybrid approach. Some tests are performed in the field, while some of the more complex tests are sent off to the lab.
Alrighty, so Les, where do we go from here?
The next thing we have to do is wait for our results to get back from the lab. Depending on what those are, those will dictate what we do next. The state permit dictates our municipality on what to do next, and that is what we call action levels. If we come back and our lab results are below those action levels, then we're good, we're okay. Now, if those results come back and they're over our action levels, then we have to step up our investigation. Looking at our results that came back from the lab, that'll give us a number of clues into where that source material may have come from.
So, stepping up your investigation, what does that involve?
If it's an industrial facility, we're going to use our analytical data and try to determine what types of industries we have in our area. Using those clues, we're going to try to find where our smoking gun might be and where that facility is that's discharging into our river system here.
Once a source has been located, how do we go about stopping the discharge?
Using our industrial analogy, we're going to use our municipality's enforcement mechanisms in order to try to stop our discharger at its point and also try to potentially stop any future discharges.
All right, Les, thanks for showing me around today and teaching me everything about IDDE. So last question I have for you today is, where's the nearest coffee shop?
We found out later that the analyses for this particular discharge came back under the Table 2 concentrations, so there was nothing else we needed to do in this case. So, I'm off to the nearest coffee shop. Or maybe I should just go take a shower first.
Okay, well, after watching that video, you probably want a cup of coffee, don't you? And don't spill it, because otherwise we'll have an illicit discharge. Thank you, Brandon. Well, welcome back to this keynote session on the chemistry of stormwater for municipalities. And that was a lot of fun, going through the section E9 and looking at detective work, using chemistry to do detective work and to figure out where are these sources coming from? What is the source of this illicit discharge? Well, there are other areas of the Phase 2 MS4 permit that also have to do with chemistry. And probably one of the biggest areas, and probably one of the most least understood, I should say, is the area of TMDLs. And we see that pop up in sections E13 with some of the testing required, receiving water testing, but especially in section E15 that talks about TMDL compliance. Now, to help us understand this, I have invited the expert on this, Bill Harris with the State Water Board, who is the permit lead for the Phase 2 MS4 permit. So, Bill, would you please join us for this part of our program? Come on up. All right, well, welcome, Bill, to the show. It's nice having you here.
My pleasure.
And I know we've talked lots about different aspects of this permit. And you are, where's your office?
Oh, okay. The State Water Board is located in Sacramento.
Okay.
And at the Cal EPA building.
Cal EPA building.
Yep.
On what floor are you?
Number 15.
15, way up there.
I guess.
Yeah. How long have you been with the Water Board?
25 years. I've been with the Water Board for 25 years. Worked municipal stormwater here for 17.
Yeah. So. Municipal stormwater has been around that long?
Yeah. And longer.
Yeah. It's hard to believe that, because I did come in. This is actually, this Phase 2 MS4 permit we're in right now is actually the second edition, right?
Correct.
And we've now completed our 5th year, right? And we're going into our 6th year. In fact, that's what your next talk is going to be all about, is what to expect.
Yep. Exactly. We've had now 2 full permit terms, one extra long with the first permit, and it was adopted in 2003. And then it was readopted in 2012.
Right. Well, okay, so I invited you to talk to us about, I think a subject that really a lot of people have a hard time getting their arms around is the subject of TMDLs. Mm-hmm. First off, there's tons of acronyms in the stormwater world. What does that stand for?
Okay, it stands for Total Maximum Daily Load. And to give a brief little summary on them, TMDLs are in fact adopted by the regional boards when a water body has been impaired to such an extent that they felt that a watershed effort needed to be conducted in order to bring back the water so that all the beneficial uses could be actually used, if you would,
Okay,
by the
so
public.
beneficial use being swimming or fishing or,
Municipal use, agricultural
Mm-hmm.
use, even industrial use in
Okay.
cases, aesthetics, fish and wildlife habitats.
Mm-hmm.
There's a whole slew of them. There's about 32 of them, I believe, throughout the
Okay.
state on what constitutes a beneficial use. But every water in the state has been assigned a beneficial use or multiple beneficial uses. And our job is to protect all of them for all the water bodies. So when a water body has been impaired to where one of those beneficial uses is no longer viable, we have to implement what's called a TMDL in order to bring that water body back so that
And,
everybody
what-
can enjoy it.
what would be an impairment? What are some examples of impairments?
Well, a very simple one could be sediment load in areas where you have excessive erosion happening due to various causes, but some of it could be due to development, construction, deforestation, or just abandoned sites. You get maybe excessive sediment into a water stream that can cause choking of fish gills. It could cause deposition of metals and other pollutants that adhere to those sediments. And so in order to then, let's say in that particular case, to scale that back, we then implement controls up through the watershed such that people are then limited legalistically, if you would, in being able to
Okay.
discharge the sediment into the river.
Okay, so impairment might be sediment. Could it be chemical?
It could be metals, it could be biological, it could be bacteria.
Okay.
It could be trash, something more
Oh.
generic. We even have some for chlorine, selenium.
Okay.
I know we tend to group selenium with metals.
Sure.
But technically, on your periodic charts you have
Yeah.
around here, you'll notice that selenium is not a metal.
Okay.
So
It could even be a condition, right? Like low dissolved oxygen or
it could
pH.
very well be, yes. Even though pH I haven't heard
Okay.
of a TMDL
Okay.
yet, but low DO, dissolved oxygen, low is definitely
Or whatever's causing it.
correct. It would be in the only one I know for low DO would be the Stockton ship channels,
Okay.
where they have dead end channels and the water isn't able to cycle, so it stagnates. And you get organic materials in there that eat up, or the bacteria eat up the oxygen when decomposing those
Okay,
organic
so
materials.
the TMDL process is one to identify all the water bodies, which obviously the State Water Board's done. Identify the beneficial uses, what that water body's good for.
Correct?
See if there's any impairments that keep it from experiencing or realizing that beneficial use to its fullest. And all right, so now we got the impairments. How do we get to TMDL, or total maximum daily load?
All right, well, the TMDL itself is not self-implementing. It's a planning document, or it's part of the planning document. You know, the regional boards have what they call basin plans. I think their real technical name is water quality protection plans, or something along those lines. I apologize for not getting those correct. But we call them basin
Yeah.
plans
Yeah.
as our shortcut. And within those basin plans, the regional board will then adopt a TMDL if needed. It's
Okay.
a long, lengthy process. It requires a lot of public input and a lot of science to go up into the watershed to identify all sources that discharge, and then to make some assumptions, but then to try to ratchet down how much each particular discharge will be able to then contribute to the overall problem, because it's a
Okay.
mass-based. Get into chemistry.
Total maximum daily load. Load's mass.
Load is mass. It's not
Yeah.
a concentration. So it's really getting into trying to look throughout a watershed to see how much mass at the bottom of the watershed, where that beneficial use will still be maintained, and then divvying up that mass throughout the rest of the watershed.
So kind of like taking the whole pie, and everybody gets a slice of that pie.
Absolutely.
Then, and if they live within their slice, then things should be okay.
Then things should be okay.
Now, so at times, does it boil down to a concentration that they have to stick within?
Well, it's sometimes as I previously indicated, going through some of the TMDLs out there, certain TMDLs don't necessarily lend themselves to a mass-based system.
Yeah.
For instance, bacteria. We don't measure bacteria by weighing it because they're so small that they have, there's some
And there's
mass there.
bacteria everywhere.
Right, exactly. So we tend to go through other metrics when looking at, let's say, bacteria. Sometimes with metals or with other contaminants, maybe chlorine, we may go back to a concentration base that if everybody discharges stays below that concentration, that then kind of like what we do with drinking water or with other sewer systems, when we chlorinate, we say you have to chlorinate above a certain amount in order to handle the bacteria or kill the bacteria. Well, so then we can say that if we can set a lower limit, saying if you don't exceed this limit, things will then still be able to live and prosper, and the chlorine is not as not an issue.
All right. So in this workshop, we're talking about the Phase 2 MS4 permit specifically. Now, we have seen recently some changes to this permit. In fact, I have right here a copy of the permit. In fact, it even says, I pulled this off the website yesterday, unofficial draft, not certified by clerk, meaning we're going to see one certified by the clerk real soon. What's the status of this permit, just real quickly?
Well, the status is that the amendment was adopted. It doesn't become effective until January 1, 2019.
Of course, we're talking about the changes. The permit is effective.
The permit is in
just
effect.
The changes
that were adopted, which this is the result of.
Okay.
This is what you have here in your hands. Incorporates all those TMDLs that we amended the permit to include. The reason we had to put out an unofficial draft was that the clerk has not certified it yet, and that makes it a legally binding document.
I mean, it just recently came out, so
it
yeah,
just recently
takes
came
time.
out. I'm positive, or let's say optimistic, that it'll come out in certified form soon. But we decided to put it out in unofficial version so that the dischargers, or the, shall we say, the permittees, know and can get their hands on their requirements, because, as I said, it becomes effective in January 1.
Okay.
So we couldn't just have that not be published, and then on
Sure.
January 1, everybody has to meet these requirements.
Now-
So we put them out there for people.
Now, E15 talks about TMDLs, but specifically, where can the municipalities find the TMDLs that really apply to them?
That would be in attachment G.
Okay.
Attachment G spells out the various watersheds within the various regions, and then lists the municipalities that are subject to any given.
Okay.
TMDL.
Okay. So we have attachment G back here, and we'll see. Like you said, we'll see a lot of different water bodies. I think it's maybe organized by water body or even regional board.
It's organized by regional board,
Okay.
and then it's organized from there within the region just by TMDL.
Okay. So some of these we'll see have specific numbers. I believe our local water body, you mentioned the Stockton Deep Ship Channel, I believe where chloropyrifos and diazinon has an actual, what we call waste load allocation, right?
Sure,
An actual number.
Right.
That you concentration that you can't go over. But a lot of these, like here we're looking at the lower Salinas River, it looks like that they're really have a lot of narrative here. A lot of you see calling out of BMPs.
Yeah, absolutely. That's one of the attachment G is the implementation requirement. It's not really the TMDL. The TMDL, like I said, is in the
that's good to know.
is in the basin plan. And again, it's not self-implementing. So then we took that planning document, read through it. Like I disseminated 78 TMDLs throughout the state, and looked at the basin plans. And I and the regional board staff, I shouldn't take credit for all this, but we put together and compiled implementation requirements.
Sure.
So then tried to lay it out in a hopefully friendly manner so that everybody could understand what they needed to do to comply with the TMDL.
I know we've spent a lot of time, my brother Steve, who you saw up here a little earlier, and our team has looked a lot at E15, and E15 can seem really broad. You could read this and go, okay, but what's this mean for us specifically? Could you just in this last few moments do your best to boil it down. I know I'm asking a lot here because it is really a big subject, but could you boil it down to just a few things that a municipality really should consider when it comes to implementing this portion of the Phase 2 MS4 permit?
Well, I think the biggest part is just understanding what you're dealing with. I mean, you have a TMDL for a reason. There's a pollutant involved, or pollutants, I should say. Shouldn't limit it to one, but a pollutant or pollutants that you're dealing with, and understand that. That's the biggest portion, because that's what we need to control. Once you understand what you have to deal with, then you can kind of go through the implementation requirements and see what BMPs or what actions are being called upon to scale back or to reduce the inputs of those pollutants into that water body. And but I think it really starts and pretty much ends with knowing what that pollutant is, how it works, and where it's coming from.
And what you're describing really sounds like the PEAIP, the Performance Program Effectiveness Assessment and Improvement Plan, right?
Yep.
That really kind of directs you through a lot of this as
in a very parallel path. I think this kind of, the TMDLs are more prescriptive, and I believe that they are, and because we've just now added them, they're kind of on the side, so they follow a parallel path to normal permit implementation. Because if you don't have a TMDL, you're implementing the permit. If you have a TMDL, you're implementing the permit plus this extra set of requirements.
So now that it's up online, and it's the thing they need to do is get that attachment G out, find their watershed, find their regional board, find the water body that is associated with their municipality, and look at what's being required.
Right.
Okay.
And maybe even conduct an assessment to see how much of a problem it really is.
All right. Well, Bill, that helps a lot. I thank you for coming in. I'm looking forward to your next talk, hearing about what we can expect to see in the future with the Phase 2 MS4 permit. But thank you for helping us understand TMDLs. So,
absolutely.
All right.
My pleasure.
All right. All right, well, that's it for our second keynote session on the chemistry of stormwater for municipalities. Hopefully you learned something. I did. Those jar tests were a lot of fun. So get out there and use chemistry to be a detective to find those IDDEs and to solve the TMDL problems for your municipality.